Hi, welcome to Nomis Academy. In this video, we are going to be looking at area under a curve under the application of integration. Now let's consider the graph. Let's consider the graph. We take here as the y-axis and then here as the x-axis. Alright, we have a curve. Let's call this curve y equal to f of x, a function. And then we have a line at this point, x equal to a, and another line, x equal to b. So we are going to find the area under this curve, or bounded by the curve, the two vertical lines, and the x-axis. Now it has been proven that the area of the curve, or the area under the curve, is giving us a equal to integral from a to b of f of x dx. So when we know our function, we slot it in the integral and then find the difference between the limits. The real number is said to be the area under the curve. Let's pick the first example. Example 1. Find the area bounded by the curve y equal to x squared. The ordinates x equal to 1 and x equal to 3, and the x-axis. Alright, so we are asked to find the area bounded by the curve y equal to x squared, and then the ordinate x equal to 1 and x equal to 3, and the x-axis. So we need to draw the curve so we can have a clear picture of the area we are about to find. So let's draw the diagram for the curve. We have here to be the y-axis, and then here we have it as the x-axis. Now we have a curve. You remember that x squared is a parabola. So the curve is going to be like this. Okay, we have start from here. It's going to be something like this, a parabola facing up. Now when we call here 1, here is 2, and here is 3. So we are looking for the area from here to here. So this is the area under the curve we are looking for. Okay, area under this curve from the limit from 1 to 3. Alright, so remember the formula given. The area of the function is giving us integral from a to b f of x dx. So that will be the area is giving us integral. The lower limit is 1 and then the upper limit is 3. Then the function, that's for the curve, which is y equals to s squared, is giving us s squared dx. So if we integrate this and slot in the limits, the real number will be the area of, or the area under the curve. So let's clean this other side to get the solution to the problem. Okay, so the area is equal to, now integrate x squared, that will be x raised to 2 plus 1 all over 2 plus 1. Then the limit is 1 to 2 to 3. Okay, so that is equal to, we slot in x raised to the power of 3 all over 3. The limit is 1 to 3. So the area is equal to, we slot in the upper limit, and that is 3 raised to the power of 3 all over 3 minus 1 raised to the power of 3 all over 3. So area is equal to, this is 27 over 9 over 3 minus 1 over 3. Okay, so the LCM is, but first and foremost, 27 divided by 3 is 9. So we have that to be 9. Or we can just take the LCM. LCM is 3. Okay, so 3 divided by 3 is 1. 1 multiplied by 27 is 27 minus 3 divided by 3 is 1. 1 times 1 is 1. So we have our area to be 26 over 3. So this is the real number. So we take this as the square unit, which is the area. So this is the area under the curve from the limit 1 to 3. So let's pick another example to buttress the idea. So to pick the next example, example 2 says find the area under the curve y equal to 3x squared minus 1 between lines x equal to 0 and x equal to 2 and the x axis. Okay, so we have this as example 2 solution. So we may not really want to draw the curve of the function, but we already understand the procedure involved. Alright, so we know the upper limits and the lower limits, and then we agree that the area of the curve is giving us integral from a to b, that's the lower limit to the upper limit of f of x dx. So in this case, f of x is giving us 3x squared minus 1. So we have area equal to integral. The lower limit is 0, the upper limit is 2. F of x in this case is 3x squared minus 1 dx. Okay, so the next thing to do is to integrate the function given. So here we have area equal to integral of this, we have 3x 2 plus 1 all over 2 plus 1 minus, here we have x, and then the limits are 0 to 2. Okay, so let's clean the other side and finish up with the solution. Alright, the area is equal to 3 cancel 3, so we have it to be x raised to the power of 3 minus x. The limit is from 0 to 1. So slot in the limit 0 to 2, slot in the limit, area is equal to 2 raised to the power of 3 minus 2 minus, now slot in 0, we have 0 raised to the power of 3 minus 0. So our area is equal to, this is 8. 8 minus 2, And then the final answer is 6. 6 square units. So 6 is 6 square units is the area under the curve between line x equal to 0, s equal to 2, and the x-axis. So we've come to the solution of the problem. Thank you for watching. See you next time. Bye.